Okay, we're going to do the second part of these notes, and I want you to still have out this sheet that we did last time, because now we're going to talk about the rhombus here, and it shows the two ways that we can prove rhombus. One is that opposite angles are bisected, so these two are equal to these two, or that the diagonals are perpendicular like this one. So we're, again, just like we did with the rectangles, we're going to fill in all the missing angles on this one and all the missing sides here. Well, we just said that this angle is equal to this one when we're talking about a rhombus. That's what we had right here and right here. So if this is 24, this is also 24. And then this is symmetric on both of these sides. So if these are 24, this is also 24 and 24. Then we also know that the diagonals are perpendicular in a rhombus and a square. So all four of these angles right here are 90 degrees. So we have four little right triangles. So in this right triangle here, we know these add up to 180, so I can do 90 plus 24 is 114 and subtract from 180 to get that the missing angle is 66. So all four, this angle is 66, but these two are equal in rhombus, and these two are exactly equal on this side as well. Now also over here, we can also figure out all the sides if I just know part of it. Once again, I know that these are right triangles, so I can use Pythagorean theorem to find this missing side here. Again, I can use Pythagorean theorem, and this happens to be the same one we did on the first page, so just look back at the previous page. This is the one we're doing, and we found previously this gives us 10. So each one of these sides is 10 because all the sides are equal in a rhombus. And our diagonals are bisected, so if this is 6, this is 6, and if this is 8, this is also 8. Okay, now a couple of examples here. If I know ADE, this one here is 42, it wants me to find EDC, that's this one beside it. Well, we just said that the two angles right next to each other are congruent to each other. So if this is 42, this is also 42. And then DEC is asking for what's this angle right here. Well, we said these are perpendicular, so this one has to be 90 degrees. On this one it says EBC, this one right here is 4x plus 12. And it says ABE, this one right here is 56. Well, what do we know about these two angles? Well, we just said those are congruent to each other, so that's the equation we're going to set up. Solve this. And we get x equals 12. And finally on this one we know AB is 7x plus 3, and DC is 10x minus 6. Well, what do we know about this side and this side in a rhombus? Well, those two are congruent to each other, so that's our equation we're going to set up. Solve this. And we get x equals 3, but they didn't ask me for what x is. I need to plug it in, and I'm plugging it into this side here. Well, they didn't have anything to plug in there. But on a rhombus, all four sides are congruent, so I can just plug it into any of these and I should get the same answer. So if I plug it in here, I get 24. So all four of these sides are each 24. Then we again are going to prove these are rhombuses with our coordinate geometry, and I can do that by showing that the diagonals are perpendicular. Remember, that's where I'm going to show that one is something like 2/3 and the other one is something like 3/2. Or I can show it by showing that all four sides are congruent. So on this first one it says to show that the diagonals are perpendicular. So I need to show that the slopes look like this. So I'm going to draw it in and I'm going to label it. So AD, what's the slope of BD here, this one? Well, it's rise -3, run 1, so it's -3/1. And then what's the slope of AC? Well, it's rise 1, 2, 3. and run 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I reduce this, I get 1/3. Does that show those are perpendicular? Yes. Here, this one, it says to show that all 4 sides are congruent. I'm going to draw it in. And I'm going to take one of these sides right here, and I'm going to do Pythagorean theorem with it. So this side is 2, and this side is 1, 2, 3. Pythagorean theorem to find the length. And we need to still take the square root of 13, which gives us 3.606. Well, so this one is 3.606. What is this one going to be? Well, its Pythagorean theorem is still 3 and 2, so it's still going to be the same thing. So we've shown that all 4 of those sides are congruent. Then our last little note here is the same note we have on the blue page. If we wanted to prove a square, we just need to choose one of our things to prove it's a rectangle and choose one of our things to prove it's a rhombus. We have to prove both of these are true, and then we can prove that it's a square. So prove that it's a rectangle and a rhombus.